Okay, so, well, getting started then, I guess, this is an example of us doing our collaborative discussion, I suppose.
I think mainly because we're wanting to have a very research-informed course, but that we can have the breadth in the course we probably would want to teach.
Yeah, I mean, certainly one of the things that we thought would be really useful with it was, while there's a certain amount of expertise that I bring to the course, and we're all keen to have these research-led, we're all research-led institutions, research expertise together with education expertise, and hopefully supports everybody. And also, the issue is once you get to that level 7 course is that it becomes very specialist knowledge, and unless you're a large department, finding more than one person who's an expert in a given field can potentially be challenging.
I mean, a large part of this for me was that I wanted the course to be very problem solving, and that whilst I could give them vast quantities of information on my speciality techniques, it doesn't kind of build in that problem solving nature.
Yeah.
And so to be able to kind of really bring in these kind of critical analysis things, to be able to solve real world problems, you need that little bit of this and a little bit of that, the types of things that we did as researchers.
Yeah.
But we were never perhaps experts on what you were doing.
There's also a potentially slightly cynical aspect to it as well, in that you're kind of sharing effort. You're if you're kind of able to assemble a course unit through building blocks from here, there, and everywhere, actually you kind of share and distribute effort between different institutions.
And I absolutely think that was massively important when I was writing these exam papers.
Yeah.
Because they were so different to any exam paper I'd ever sat, I'd ever seen, or I'd ever written.
I mean, there's that kind of aspect you say about the examination, the open note nature of the assessment meant that actually researchers who might not necessarily be fully aware of, I mean, coming back to that education research bridge, it actually gives confidence to researchers who've been involved to actually innovate and do different types of assessment and have confidence in that as well.
Given the technological change that we've seen in the 20 years since I did my degree, I think open note assessment is a far more kind of valid technique in today's society. It's not the fact that you have to remember something, it's the fact that when you Google it, you have to be able to understand it. You have to move beyond this point that you just blindly believe whatever you're told. You have to move beyond the point where you believe that the world is flat.
I suppose one aspect of doing this video is showing how we do it. How can we make this happen? And I don't know what the internet connection is like for you, but certainly this feels like a natural conversation. So.
Yeah, I mean, we don't normally record in a Google Hangout. This was just the way that we could record this conversation, but certainly a lot of kind of FaceTime calls, a lot of messaging people, a lot of emails.
Yeah, and actually it's, in a way, it's much more natural than a phone call, because certainly you're there pressed with a phone against your face. Yeah, and there's informality as well with messaging as well, which there isn't with the email. It's instant communication. Yeah. Actually, the way things are makes it very easy for you to send a message from your phone with a picture that you've taken. I mean, certainly, yeah, one thing that I know we find useful is using Visualizer.
Yeah, I can see that.
So, this just allows me to kind of draw out structures and sort of describe how a particular spectrometer might work, through introducing, say, a time gate, for example, so that this basically gives you a delay in your optics line, which allows you to essentially you can adjust time offsets by just changing this path length. And there's something about being able to just scribble it down and have you being able to point at it very, very easily. It feels very natural to me. I don't know how it looks your end, but
it's slightly off picture at my end, but it's something that I found so useful. I've brought into my distance learning teaching as well.
Yeah. We kind of started collaboratively editing PowerPoints, really, didn't we? But certainly one of the things that I found working on this course was that there was far more scope for creating and sharing our own graphics.
Yeah.
And certainly, it's something that that we did with a shared Dropbox, was creating graphics in PowerPoint. Just understand how much you can do in that very basic drawing environment or the sketching environment. So, I mean, we didn't use exactly the same content, I don't think, did we? We kind of worked on stuff together, but there was a lot of extra.
Yeah, I mean, the core of the course was kind of built together, but I think the kind of embellishments on the course were done separately. I think that the workshops I used were different to yours.
Yeah.
And certainly the second time I ran the course, I ran my workshop differently to how I ran it first time. And I think that kind of pulled it even further away from what you did. And I'm the person that has the mixed class. So mine goes to both level 3 and level 4. And so I'm trying to essentially deliver level 4 material, master's level material, and I've got some third years in the class. Of those third years, a lot are very capable because a lot of them are natural scientists who come from a physics background. Actually, the level 3 natural scientists and the chemists, I think the fourth year chemists are two groups that go together quite well. The natural scientists really like this course because they can see it bringing together their physics and their chemistry. It wasn't designed like that, but I do think that's naturally a kind of spectroscopic thing. I have my first degree in physics.
We had to meet the needs. So what we were delivering for was chemistry with molecular physics students. So there's perhaps much more of a focus on the kind of the mathematical physical side of things.
I tried to build very much, it was a case of, okay, I'm going to give you these pieces of a jigsaw, but these pieces of a jigsaw can be put together in different ways.
Yeah.
So it was a case of, you get these basics, and then I'm going to focus on how we can bring them together. That kind of problem solving aspect, that's very much how I kind of tailored my course. Very, very kind of problem solving, because then there's levels of how you can approach that problem solving. You can either kind of go through it with a very much a case of what you have these results, what do these results show you? Or you can go through it with a case of, okay, you think this is what's going on. What experiment would you do? What results would you expect? And I think one of the most important things for me in this course is there is no correct answer.
Yeah.
Any
that's a key
scientifically justified answer is correct. The better built the story of why you think this, the more marks you get. But it can be completely different to what either I think or what the paper thinks. As long as you've justified it scientifically, you get full marks.
Yeah, and that's kind of the key thing, is that showing, because it's a research-driven course, actually that's much more authentic. It's much more realistic in terms of what we do as scientists, in terms of...
And I think that's that kind of self-authorship. It's this idea that you don't need... It's not remembering a fact. It's you constructing your knowledge out of the bricks that we've given you.
Yeah.